One of the earliest math concepts that is taught in elementary schools is place value. Starting in preschool sometimes, and certainly in kindergarten, we talk to kids about bundling, about groups. But I wonder when we teach place value at those very young ages and also later on in the elementary years, if we really emphasize what place value is and why we have it. We really need to get back to the basics with this one to have students understand the purpose of place value. For example, if you look at the picture on the left and you see all of these pennies, this is a good way to introduce it to students, not only at a very young age, but even later, to remind them what this system is all about. So if I had a big bunch of pennies and I asked my students to count them, put them all on a table in the middle of the classroom and said, I want you to count them. We're going to share the work here. How are we going to do this? As students look at this very large task of counting this pile, they might say, well, we'll all count at the same time. But the only way that that's going to really work is if they group them into groups so that later we can go through the groups and count them quickly. 10, 20, 30, 40. So they could group them by 10, they could group them by 50, they could group them by 100. But that's what place value does for us. And I'm not sure we're very intentional about making this very clear to students. Before we work only in base 10, I think it's important for students to understand that numbers can be grouped by any number, and that place value is not always base 10. Sometimes we have base 2. As we work with computers, we work in base 2. Sometimes there might be a base 4, a base 6. So what we want students to understand is that place value just means we're grouping by a certain number. And when we get a certain size group, and we get that many of that group, then we go to the next place value. So for example, here you see pennies. Let's just say that there are 63 pennies there. Well, we can group those pennies in a lot of different ways. We could group them starting in base 2. And in base 2, that would mean that every time we make a group of 2, and then we get 2 of those groups, we're going to go to the next place value. So for example, we have a ones place, just in case there are any leftovers. Then we make a group of 2. When we get 2 groups of 2, we make another group, which would be a group of 4. When we get 2 groups of 4, we would make another group, which is a group of 8. 2 groups of 8 means our next groups would be 16. And 2 groups of 16 means our next place value would be 32. And we could keep going. Notice that every time we go from the ones to the group size to the next group, it's 2 times the group before, because we're in base 2. So that's what 63 pennies would look like if we grouped them in base 2. We would have one group of 32 pennies, 1 16, 1 8, 1 4, 1 2, and 1 1. And if the students counted up all these dots, they would see that there are 63 of them. What does that look like if we write it in base 2? It looks like this, because we have one group of 32, one group of 16, one group of 8, one group of 4, one group of 2, and one leftover 1. So our number would be 1, 1, 1, 1, 1, 1, base 2. Now we could also group our 63 pennies in groups of 4. And if we did that, we would start with our ones place, and then we would make a group of 4. When we got 4 of those groups of 4, that would be our next place, and that would be a group of 16. And when we got 4 of those groups of 16, that would be our next place, which would be a very big group because it would have 64 in it. So again, if we group our pennies in base 4, we have the ones place, then our group of 4. When we get 4 of those, we have a group of 16. When we get 4 of those, we have a group of 64. So if we organized our pennies in base 4, we would end up with 3 groups of 16, 3 groups of 4, and 3 leftover ones. Not enough to make a group of 4. So what would we have here? As you look down here, you could see how we would write this. 3 groups of 16, 3 groups of 4, 3 leftover ones, base 4. So what's interesting is, if we counted out 63 pennies, we could organize them this way, we could organize them this way, we could organize them in all kinds of different ways. And we would still have 63 pennies. The number does not change, but it can be represented differently. This seems quite complicated, and it's not something that I would do with very young students, at least not with the numbers. But there are kind of fun activities that can be used to show kids that we're just grouping by different numbers. We can group by almost any number that we want to. And that's what place value is. Just saying we're going to group, and we're going to make our groups this size. Then we can make sure that students understand that we have chosen to have our number system based on a base 10. So even though we can group by any number, our number system is based on groups of 10. So we have a group of 10, then we have a group of 100, then we have a group of 1,000. So they understand that this is just a choice that was made for our number system. Once we get to base 10 and we really center in on the system that we use for most of our number operations, then we want to make sure again that we back up to the very basics. We want students to understand that the really cool thing about our number system is that there are 10 digits. We have 0 and then the numbers 1 through 9. And out of these 10 digits, we can make almost any number. There are so many possibilities. We can use those digits, and just by putting them in different places, they mean different things. So for example, if we look here, our place value is based on the system you see on the picture here. So starting from the right, we have the ones place, the tens place, the hundreds place, the thousands place, and the 10,000s place. So this 3 here happens to be in the hundreds place, ones, tens, hundreds. That means we have 3 of these. This 3 happens to be in the ones, tens, hundreds, thousands place, which means we have 3,000s, which doesn't even show in our picture. This 3 is in the ones place, which means we have 3 of these. So 3 of these, or 3 of these, or 3,000s, which would be even bigger, which would be 10 hundreds, are very, very different. And we need to make sure that students understand that. They need to see a digit as not just a digit. They need to see the value of the digit as we teach place value. Once we've taught place value well, so students understand the purpose of it, what it means, then we can get into the number families. And we can make sure that they understand how to work with place value. One of the things that really helps students is to simplify this a little bit and to think of large numbers in families. So if we look at, for example, the blanks that you see here, students could fill in those blanks and write a very, very large number. But as we think about place value, sometimes what we have students do is just memorize ones, tens, hundreds, thousands, 10,000s, 100,000s. And what happens often is that students get confused. If they leave one out, they're all mixed up. So I think what we want to do is we want them to understand that every family has the same family members. So we have ones, tens, hundreds, and then we go to the next family. And in the next family, we again have ones, tens, hundreds. And in the next family, ones, tens, hundreds. Then we can teach them that these commas represent family names, like last names. Just like they have a last name, our number families also have a last name. So if we start again, in each family we have ones, tens, hundreds, starting from the right, ones, tens, hundreds. Then we hit the family name. So this is the thousands family. So what do we have now? 1,000, 10,000, 100,000. And then we hit a family name. That's millions. What do we have now? 1 million, 10 million, 100 millions. So 1, 10, 100, 1, 10, 100. Keeps repeating and repeating no matter what family we're in. And the only thing that changes is that last name of the family. So the comma is the family name. And when they read large numbers, it must be spoken. And within each of those families, we have 3 family members before we get to the next family. So when we're writing large numbers, we need to teach students that we can't leave any family members behind. So at every family, there has to be 3 places for the family members. We need them to understand that the comma represents the family name, and then there are 3 members in the next family. So as they write large numbers, it's going to end up looking like this. But we want to, at the very beginning, make it simple for them to think about how to write these numbers. So something that we can do is to have them write what they hear. So for example, in this top number, they hear 4 million. Million is a family name, so that means a comma. 323,000 is a family name, so that means a comma. 563. And after they write the number, we go back and we look. Do we have 3 family members in those families? Now again, we're going to have to deal with the fact that here we don't have our family members represented. So that's a separate thing that we need to teach, that when we're starting a number, it's possible that we can put zeros there if we want to make it very clear, but that we don't really have to because it won't change the value of that number. When we get to numbers that are a little less easy to hear, sometimes it's still good to tell students, write what you hear first, and then let's go back and look at the families. So in this next one we have 23 billion is a family name, 75 million is a family name, 146,000 is a family name, 5. What students did there was to write what they heard. Now, when they go back, they need to say, okay, but we need 3 members in each family. How are we going to add zeros for those family members that are not filled in, that are not shown, without changing what we heard? So if we think about that again, 23 billion, students might want to put the 0 here, and that's okay if they do. 75 million. If we put the 0 here, it doesn't say 75 anymore. It says 750. So again, where can students put that 0 so that the number still says 75 million? 146,000, that family has 3. 5. If students put the zeros here, it doesn't say 5 anymore. It says 500. So where can they put the zeros where it will still say 5? For many students who struggle with writing large numbers, being able to think one step at a time is very helpful. Write what you hear, write the family names, now go back and make sure that each of your family has 3 members. And while we're teaching all of this, we want to make sure that we are emphasizing the fact that this is just a system. This is something that was designed to help us make sense out of quantities of things that we see. It's like the alphabet, it's like words, it's the language of math. Place value is everywhere. In other math concepts on this website, you're going to see place value mentioned in addition, subtraction, multiplication, division, fractions, decimals, percent. It's everywhere. And if we don't teach it very, very well, students are going to struggle. And this is something that we don't only teach at the younger grades. We need to make sure that students in the older grades, 3rd, 4th, 5th, 6th, even above, are using place value, because place value is the meaning of a number. It's the meaning of the digit.